Alright, so we are asked to factor this expression. It's not a trinomial, it doesn't have a GCF, and it's definitely not the difference of squares. 3, 4, 9, and 12 have no common factors. They don't even have common variables between them all, so there's no GCF. It's not a trinomial, because it has 4 terms, and it's not a difference of squares, because it has more than 2 terms. So grouping is usually our backup method for factoring here. Now, we don't have to split any terms like we did with the trinomials, because we actually have an even amount of terms. But the question becomes, how do we group them? What two terms do we put together? And the answer is whichever ones work. Sometimes it works for multiple groupings. So just as an example, we'll group the first 2 terms and the second 2 terms. Alright, now we find the GCF of those 2 terms. GCF of 3x to the third and 4x squared is x squared. And that'll leave over 3x minus 4. Okay, see that in green. The GCF of 9x minus 12 is 3, so that's positive 3, leaving over, I believe, the same thing, 3x minus 4, which is the point of grouping. We want to see if we can find this common polynomial factor. So we can factor out that 3x minus 4 from both of these 2 terms. These are 2 different things. And that leaves over just this, x squared plus 3, which cannot be factored any further. Alright, so I'm going to erase this, and we're actually going to try and group it another way, just to show you that you can group them different ways. Might even do it in all 3 ways. I think you can do this problem. Alright, so let's erase all that. Alright, so we group the first 2 terms together. Why not group the first term with the third term and the second term with the fourth term? Alright, so I'm going to rearrange the example. What's the GCF of 3x to the third? Let me rewrite it just to make sure it's clear. So this is going to be 3x to the third plus 9x minus 4x squared minus 12. So I've reordered them. Now it looks like it did before. So this is one group, and this is another group. Alright. The GCF of these 2 terms is 3x, leaving over x squared plus 3, which should look familiar from before. Let's do that in another color maybe. Make sure this is clear. GCF is 3x. Okay, the GCF of these 2 terms is negative 4 and has a remaining portion of x plus 3, x squared plus 3. So now the common polynomial factor is x squared plus 3. When we factor that out of these 2 terms, 1 term, 2 terms, that leaves over 3x minus 4, which is the same thing we got before, except now they're in a different order. But if you remember, the commutative property says the order in which you multiply 2 values will not change its result. Let's try rearranging them again. I haven't tried it in this other one. I've done these 2 before. I had to reshoot this video about 5 times. Alright. Whoa, that erased more than it was supposed to. So I'm going to erase this. Alright. Let's group these middle 2 terms together. And these end 2 terms together. So those 2 and these 2. So I'm going to rewrite it. So that's 3x to the third minus 12, negative 4x squared plus 9x. Now, I've never tried this. I don't know if it'll work. What is the GCF of these 2 terms? It looks like it's just 3, leaving over x to the third minus 4. Now, this is not one of the factors from before, so I don't think this is going to work. But it's about choosing them wisely. Make that a little different. Alright. These only have a common factor of x. I guess technically minus x. Negative x, and that would leave over a 4x squared minus 9. And as we see, these are not the same, so we can't take out a common polynomial factor. So sometimes, I guess the values you choose to group together will affect your ability to factor completely. This looks like it's factored, like you can't factor it completely, but you can, as you saw in the other two examples. Let's look at another one that looks harder but isn't. Alright, so the question becomes what terms to group. And my recommendation is always to look for the numbers that have the largest amount of factors that you could tell they have in common. For instance, 140 and 60 definitely have a factor of 10, so they kind of stand out, so let's maybe group those. I think that these both have a common factor of 12, so we'll group those. 20 goes into both of these evenly, so let's factor out 20. X goes into both, so that'll leave over 7y minus 3x. Okay. And these have a GCF of 24. No variables, so just write down what's left here. 24 goes into 68. I don't remember how many times. Let's find out. Where's my calculator? There's my calculator. Turn that on. There it goes. Alright, 168 divided by 24 is equal to 7. Alright, so 7y minus 12 goes in here 6 times, so 24 must go in there 3 times. And you'll see there's a common polynomial factor of 7y minus 3. So 7y minus 3 is one of our factors, and the other one will be what's left over, which is 20x plus 24. Okay, and I also haven't tried grouping this one in different ways, so might as well experiment. You'll see it'll work more often than it doesn't. Let's erase this. Okay, so almost done erasing. Okay, so I'm going to rearrange these terms. So instead of these two, let's do every other term. So let's switch. Can I grab that piece? No, I can't. Negative 60x squared. Okay, move that over again. And I'm going to move the 168y over here, just to see if it will work. Doesn't mean it will. Sometimes you can tell where the better terms are. Alright, so 140 and 168 have a GCF of what? I don't know. Let me use my calculator, because sometimes it takes a while just to do something like that. Under number, go down to GCD, greatest common divisor, which is another word for factor. I can punch in 140, comma 168, and it says the greatest common factor is 28. Okay. So, factoring this, we get to 28y, and what goes in here? 28y, how many times is going here? 2, 3, 4, I think it's 5 times. 5 times, right? Let's check. just to be sure. 140 divided by 28 is 5. That's 5. 5x plus, goes in here 6 times, 6. Okay, and let's factor the other one. What goes into 60 and 72 evenly? 12 does. Matter of fact, in this case it would be negative 12. X goes in here 5 times, with x left over, and goes in here 6 times. Look, common polynomial factor. So one of them is 5x plus 6. The other one is what's left over, which is 28y minus 12x. These don't appear to be the same as they were before. Oh, I think I see why. This isn't factored completely. This term doesn't have a GCF, but this one does. So this can actually be factored further. It probably could have been factored further before and I didn't notice. Let's see. Let me erase this just for space. But this has a GCF of, what, 2 goes into both of these? 4 goes into both of those. So that's 4, 5x plus 6, and when we factor out that 4, that leaves us with 7y minus 3x, which looks familiar. I think that was the factor from before. So this is now factored completely, because none of these terms can be factored anyway by trinomial, GCF, difference of squares, or even grouping. You can't group two terms and factor. All right, thank you.